like to talk about the elements that are found between transition metals going over to group 7. So we are actually going past the boundary which changes from metallic elements over into non-metallic elements. What's so special about it? Well, you need to understand. In a periodic table, we organize it such that when we go from the left to the right of the periodic table, going from group 1 all the way towards group 0, group 7, group 0, that direction, usually left to right, we are actually moving from metallic elements into non-metallic elements. The change is pretty gradual. It starts with group 1 where it's extremely metallic and very aggressive. And as you move towards group 4, group 5, or group 14, 15, you'll start to see increasing amounts of non-metallic properties and decreasing amounts of metallic properties for each element as you move across. The boundary between metals and non-metals is not a very clear line, but as you're shifting over, you would notice that certain properties are changing. Let's give you an example. Tin. Let's talk about tin. Tin is obviously in our minds, mostly it's a metal. It's the idea of a metal because we have things like tin can and all that. But guess what? When we are talking about the compound tin chloride, okay, tin chloride is a metal bonded with a non-metal. If the question was to ask you, so is this an ionic compound or not? Most people would say, yeah, sure, it must be ionic, right? Wrong. So what happens after that is that the question will usually develop and they will tell you, but you see, tin 4 chloride actually has a low melting boiling point. Then you wonder, why is it low melting boiling point? It shouldn't be, right? Ionic compounds tend to have high melting boiling points, correct? Yes. Ionic compounds tend to have high melting boiling point, but tin 4 chloride is not ionic, it's covalent. So this is what I mean when I say when you move from left to right, you start to decrease in metallic behavior, you start to increase in non-metallic properties. So even the compounds that are formed by some of the metals around the boundary, they actually look like ionic, but they could actually be covalent. Always let the evidence of the properties guide you on what the structure should be, because the properties are as such following the structure of the compound. They cannot have high melting boiling points unless they are ionic compounds. So if they show themselves up to have low melting boiling points, you have no choice but to say that probably they are covalent compounds. Understand? Despite the fact that the name looks like it's ionic compound. So I hope I make this clear. This can happen not just for tin. Another popular example will also be aluminum chloride. Okay, these two, look out for them. Okay, so for now, I will stop it here. If you like what you hear and you like to show me your support, please click the like button. I hope you subscribe to my channel. Be sure to come back for the next video. I'd like to talk about the rightmost group, and that will be the group called the noble gases, or group 0.
I got my head out the sunroof, I'm blasting our favorite tunes. I only